Chain, chain, chain. Chain, chain, chain. Chain, chain, chain. Chain rule.
All right, my young math enthusiasts, here we go with another set of examples for the chain rule. So this is basically finishing off the packet that we did the other day in class. So if you have that, take it out. You can finish up your notes. The expectation here is that you're just going to do a couple more applications of the chain rule. Maybe learn one or two new things on this nice Sunday afternoon, or maybe it's Monday night if you're waiting to the last minute. And then we'll be ready to move on when we come back to class on Tuesday. So in example number 5, you're asked to take this polynomial function x squared plus 4, raise it to the 10th, and find dy dx for it. So I think we all know how we go about doing this. We're first going to define our f and our g. So our f of x is going to be x to the 10th power. Our g of x is going to be x squared plus 4. And f prime of x is going to equal 10x to the 9th. And g prime of x is going to equal 2x. So finding f prime of g, 10x to the 9th, when evaluated at x squared plus 4 would be 10 times x squared plus 4 to the 9th power times g prime, which is 2x. So we would have dy dx equaling 2x times 10, which is 20x, times x squared plus 4 to the 9th. And I think what we recognize in this one is that although we're applying the chain rule, we're really applying the power rule as well, because we have a power function x to the 10th, and we're evaluating at a quadratic function. So the 10x to the 9th piece we know from our power rule that was going to come out, and then our g prime is right here. So this actually has a special name, and that's what the next statement in the notes talks about. So in this statement we have, if we have some function y which is equal to g of x to the n, and I know, apologies for using g's and f's all over the place, but if we have y equals g of x to the n, so a composed function raised to the nth power, y prime is always going to be found by first applying the power rule, n times g of x now raised to the n minus 1 power times g prime. So apply the power rule first and then apply the chain rule, and you get yourself what y prime is. This is what often mathematicians refer to as the power chain rule. And power chain, obviously, because it's the power rule with the chain rule inside of it. So the power chain rule. It will save you some time from having to rewrite all of your f's and g's and f primes and g primes, because it always works out this way. Alright, so here's an application of the power chain rule, and maybe you're looking at this and saying, this is not a power chain rule problem, this is a quotient rule problem, at which point I would say, I bet you it's a little easier to do as a power chain rule problem than it is to do as a quotient rule problem. So why don't you pause the video for a second and actually attempt to rewrite this rational function as a power function, and then apply the power chain rule and simplify your answer. Don't cheat, don't just watch it, give it a try. Do it on a separate sheet of paper, and then when you come back, I will have for you the simplified answer. Alright, so take a second, pause the video, and go ahead and do that. Alright, here we go. So hopefully you were able to rewrite this as x squared plus 2x plus 1 to the negative 1/4 power. Now we have a power chain, so we can do our n times f of x to the n minus 1 times the derivative. And we do a little simplification, so dropping this whole piece to the denominator, because it's the negative 5/4 power, making it the 5/4 power. I leave the negative at the top because that is in the numerator of the fraction. And I bring the 2x plus 2 over. So I have the opposite of 2x plus 2 over our function, and I can do a little cancellation here. My negative is going to stay, but my 2 and my 4 reduce to a 1/2. So negative x plus 1 all over 2 times x squared plus 2x plus 1 to the 5/4. Now, I know that some of you may see it and you're going to be asking, oh, x squared plus 2x plus 1 can be factored to x plus 1 times x plus 1. We're not going to simplify that. Obviously, if a particular question had a simplified version of this, where they factored the denominator and canceled something with the numerator, you could go ahead and do so. But at this point, this is as simple as I need it to be.